And an important part of this course is really hands-on experience, because I mean you can read about microcontrollers or embedded system all you want. In the end, that's not going to help you. You got to get your hands dirty, and that means really try to write programs to get it to do real things, work on really concrete level, and this is really at the interface between hardware and software. This doesn't necessarily mean you have to build actual hardware, but you need to at least understand hardware at pretty intricate level, and also understand how these signals or how digital values are represented at the low level. And now, first part of the course, you get your hands-on simulator, because that's much easier to manage. You actually learn quite a bit that way. And that's the foundation. And then once you have that, then the second part of the course has to do with building a real system on real hardware and so forth. And in this case, the board will be providing you at least one of them is based on the Bluetooth 4.0 low energy technology. I don't know if you heard of this one. It's part of the new Bluetooth 4 standard. Not all phones have it. Most phones are probably still 2.2 or what's called Bluetooth BREDR, basic rate, extended data rate. But Bluetooth 4 came out in 2010 or so. And it's been built into like iPhone 4S or Android 4.3 devices and so forth. And it is much lower power or much longer lasting than traditional Bluetooth devices. And so it has gained a lot of popularity in the past year. You'll see a lot more Bluetooth 4.0 devices on the market. And my lab, we've been building real embedded systems for, and by real, we mean there's real users outside our lab, not just we build things in our lab and for our own amusement. There's real world users of our Bluetooth 4.0 systems. And one nice thing about this compared to many other radios you find in embedded systems is that essentially all new smartphones can talk to a Bluetooth 4.0 device. And that's nice. That's pretty cool, because that gives you a lot of direct interaction, or between a nice personal user interface and an embedded system that can do real things, can control a robot, can turn lights on and off, and cause real things to happen. Okay, so and so that's what we plan to do. And there may be a few other options, but I think by default we like to get people to try the Bluetooth 4 board, which we call EcoBT, and I'll show you in a little bit. Okay, so the hands-on part is very important, and I think once you have good skills from getting hands-on work done, then you'll be very valuable. Lots of companies will want you to work for them. So that's been our experience. Okay, so now to get started, I'd like to show you a simulator just to give you an idea of what an embedded system could be like. So what you do is go to the website called edsim51.com, and then you can see. Okay, now, okay, here. So that's the website, and you'll see there is Edsim 51 version 2, right? Introducing Edsim 51 Di, and if you go down a little bit, there is Edsim 51 SH. So SH is more of a customizable one. For most of the purposes, you probably want to use the DI. DI stands for Dynamic Interface, and to get the Edsim 51 DI simulator, Now, free, good. Free is good. Okay. So then let's go in, and so that's kind of what it looks like, and as an interface. It's just not. It's not just a screenshot. It's real. So let's see. Where can I download it? Okay. Didn't I just click on download? No, maybe not. Okay. Click on this one. Okay, that's just a screenshot. I downloaded just before class, so it's okay. Oh, there. So it showed a little down. You just have to click on this picture here, and then it decodes it. I think show downloads. Okay. Okay. Then it's already there. So let's run it. It's a Java app, so you don't have to do any installation. It should just run. Okay, and there it opens up, a lot like what you see on their website. Okay, so there, easy to install, huh? Not too bad. Okay, and let's go back to the slides. Where am I? Oh, no, this is not the right file. Not the right file either. Okay, there. Okay, so there's two versions. You could try the other one too, the SH. That's customizable interface. But let's try this DI one for dynamic interface. So what are you looking at here? Well, you're looking at mainly what's called the peripherals, or the I/O devices of this embedded system. I/O for input/output, you probably know, right? So here you'll see a few things. There is a bunch of buttons, a keypad, and this thing. I don't have a way to point, but the lower second box from the left, that's an LCD, or liquid crystal display. That's where you can display characters, digits, symbols, and so that's you find these in a lot of embedded devices, like a fax machine, for example. There's an LCD panel, or sometimes printer has this 1-line or 2-line LCD, right? And then to its right, you see the 8888. Well, those are the LED, like you find on elevators, right? Which floor it's on. So these are what's called 7-segment LED. And so when they're lit up, they're red, and otherwise they're different color. And then above the 8888, you'll see this one called. This is really what's called UART, or a serial port. This is the older way to connect like any device. Could be a modem, could be a printer, to a computer. UARTs are not used as much anymore since USB took over, but you can still get these serial ports using a UART adapter, or a serial port adapter. The reason they're there is because they're very simple. And we'll spend some time just explaining what UARTs, how UARTs work. And then there's ADC, for analog to digital converter. Because, as you know, when we write a program, we're dealing with digital values. But an embedded system often has to work with the real world, which is analog. So that means it's not a 0 or 1, or low voltage, high voltage. There's a voltage in between, okay? And so an ADC allows you to convert a digital quantity, a binary number, to, say, some different levels of voltage in between, okay? And then one of the things you can control is like a motor, so motor enabled. So you can control like how fast a motor has to spin, like your fan, for example, right? You want stronger wind, or not as strong, depends, right? So those can be controlled digitally, but the way they control is they just switch on and off very quickly. rather than using an ADC. Okay, so there's different ways of controlling analog devices from the digital side. Of course, there's also the DAC on the lower left. DAC stands for digital to analog converter. So yeah, that's ADC converts from an analog to a digital value, right? So you give it a voltage, you get a binary number out of it. DAC is the other way, right? You give it a digit or binary number, it gives you a voltage out. Okay, so so in any case, this little simulator actually covers most of the basic concepts of what an embedded system can do, at least with the interfacing level. Okay, so that's kind of nice. And of course, embedded systems is more than that, and that's where I hope to make up for this one by introducing like the Bluetooth 4, because that has much more of the software and communication protocol aspect and some operating system as well. Here, you can do everything without communication protocol, without software stack, or without an operating system. Okay, and EdSIM itself is also what's called cycle accurate. That is, it can simulate execution of instructions to the exact cycle. Okay, that is, you can predict exactly how many microseconds it will take. That's pretty good. Okay, this one is a screenshot I took from the website EdSIM51SH. This one is the customizable one. So compared to the previous one, you see, wow, everything up there. But you might not be using everything. You might use only a subset of the devices. So this one says, okay, you can hide the ones you're not using and then concentrate on the ones that you want to use. So if you just want to have one single light as the only thing it controls, okay, hide the other things. And so that's less distracting.